we let y, so we let y to be f of x, which is x to the 2 plus 1. And let's say simply that y is equal to x squared plus 1. Okay. If we add a small change in x, that will result to a small change in y. And consequently, I'm going to have on the left-hand side, y plus change in y is equal to, on the right-hand side, what caused this small change in y is small change in x. And so we have x plus change in x raised to power 2 plus 1. Let me call this one equation number 1, and I call this one equation number 2. I want to make change in y the subject of this equation. So to do this, I have to subtract 1 from 2. So that means 2 minus 1. What this will give me is, on the left-hand side, I have y plus change in y minus y is equal to, on the right-hand side, I have x plus change in x all squared plus 1 minus x squared plus 1. Alright. If we consider what we have on the left-hand side, y minus y is 0. We are left with change in y. So on the left-hand side, I have change in y is equal to, on the right-hand side, I need to expand x plus change in x all squared. Observe or recall rather that a plus b raised to power 2 is a plus b multiplied by a plus b, which is nothing but a squared plus 2ab plus b squared. So we're going to apply that here. And if we do, this will give me x squared plus 2x change in x plus change in x all raised to power 2, then plus 1, minus, I open this bracket, I have x squared, then minus 1 also. Minus 1 will cancel each other, that is 0. X squared minus x squared is 0 also. So we are left with what? We are left with 2x times change in x plus change in x all raised to power 2. So this is what we have. So change in y is this. Now, our goal is to find change in y with respect to change in y, with respect to change in x. So I divide both sides by change in x. And so I have change in y divided by change in x is nothing but 2x change in x divided by change in x plus change in x all raised to power 2 divided by change in x. Again, this leaves us with 2x plus change in x. Because this will cancel, one of these will go with this, we're left with that. So change in x with respect to change in y is 2x plus change in x. The convention is that dy, observe the change, I write dy by dx. This is, by definition, the limit as change in x tends to 0 of change in y by change in x. I'll come back to these notations immediately we evaluate the limit. So I give the different names to this and that. So this is nothing but we have computed change in y with respect to change in x, and we got 2x plus change in x. So so this is nothing but limit as change in x tends to 0 of 2x plus change in x. Notice here that in the first term there is no change in x, so it is a constant as far as change in x is concerned. So if you take the limit, it will not affect this, we simply get 2x. If you go to the second term, as change in x tends to 0, this second term becomes 0. So everything here reduces to 2x. Hence, the derivative of y with respect to x is exactly 2 times x. That is how to use the definition involving delta change in x to compute the derivative of a given function from the first principle. Now, observe the difference between this and this. We call this one delta x. Delta x. Whereas we call this one dx. Same way, this is called delta. Oh, tell me, this is delta y, please. Whereas this one is delta x. And then this is dx. So of course, this is straight d, this one is delta in form. So this one indicates small change in x, whereas this one indicates the full derivative with respect to x. So get used to these notations. And then you can see what happened here, that what we're saying is that as change in delta x approaches 0, what we get is what we call dy by dx of this quotient. So this is the whole idea behind differentiating from the first principle. Okay, we shall take another example that is interesting to see how to get the derivative of some trigonometric functions from the first principle. All right.